what we did in grade 11, if you were in 20-1, if you were in 20-1 last year, you would have done rationals already. If you were in 20-2, you probably did go over rationals as well, because we asked them to go over rationals as well with you. If you were in 20-1, you would have done rationals with product sum factoring. So it was like a whole big schmozzle. You'll remember it, because it was literally like, what plus what gets me what plus what gets me what, or what times what gets me what. And you have to factor the top, factor the bottom, factor the top, factor the bottom. It was like this big deal. It was like x squared plus 3x, don't write this, minus 4 over 2x squared plus 6x minus 2 times 3x squared minus, and it kept going. It was two big quadratics if you did it in 20-1. Great thing about 30-2, you don't have to factor trinomials.
Yeah.
The most you have to do is GCF and difference of squares. That's it. So, the unit itself is a lot to learn, and this is one of the units that people struggle the most with because they don't practice enough. So you're going to be using your textbook at home and doing practice questions as well for this unit. But what you need to remember is you don't have to trinomial factor. So even in 20-2 or 20-1, you trinomial factored. In either of the courses, you have to do it, which is product sum and decomposition. We don't have to do that this year. Okay? So the only thing to do is GCF or difference of squares. So we're going to practice those to remind ourselves. So the moment we have two factors, it could be a difference of squares. But the key to difference of squares is it has to have a difference sign. A difference sign is a subtraction sign. So the moment there's an addition sign in between, all you can do is GCF. All you can do is greatest common factor. That's it. Or nothing. Those are your two options. So this one has a plus sign in it, and it says factor. So the only thing I can do here is GCF. Now, what number can I divide 25 and 45 out of? What can I take out of both of them? A 5. So I write that up front. So this equals, and we need to have an equal sign because this equals 5 bracket, oh, 4 bracket, sorry, don't put the bracket. 5, how many D's can I take out? This one has 5 D's, this one has 4 D's. 4, right? So you write D to the 4. So our coefficient that we take out, we do division. When we take a variable out, we're just taking out that many. Okay? So when I go 25 divided by 5, what do I get? 5. If I have D5 and I take out 4 D's, how many D's do I have left? 1. So I have a D, so I have 5D. Then a plus sign. Then what's 45 divided by 5? 9. And then I have 4 D's and I take out 4 D's.
0.
So I have none left and I'm done. That's it. This one, it has 3 terms, right? The moment you have plus or minus signs, it makes a term. So 1 term, 2 terms, 3 terms. I told you that you don't have to do trinomial factoring. So if you see 3 terms, GCF is what's going to happen. So what can I take out of 9, 12, and 6? 3. What can I take out bigger? Can I take anything bigger out? No. Some people say 6, but can I take 6 out of 9? No. So 3 is the biggest. So we're going to go this equals, so make sure you have an equal sign. That's very important. Because this equals, and we're going to do the simplified form of that, right? That's all this is. If I distributed my 5D4 back into this one here, if I distributed my 5D4 back in, I would get A, right? So I can double check my work by distributing it back. So I can take out a 3, and then I have K4, K cubed, K to the 1. So this one has 4 Ks, 3 Ks, and 1 K. What's the most I can take out? Just a K. Then I have a bracket. 9K to the 4, if I take out a 3K, what am I left with? 3K3. Because 9 divided by 3 is 3. K4, take out one of them, is K3. Then I have a plus sign. Then I have 12 divided by 3 is 4. K cubed, take 1K out. K to the 2. Minus sign. 6 divided by 3 is 2. K1, take out K. Good. Box it. Now remember, we should be able to check it, right? We don't want to do this. We don't want to distribute it back in because we get exactly what we have. But we can check it to see if we got exactly what we had. 3k times 3k cubed, 9k4. Yep, that's good. 3k times 4k squared, 12k cubed. That's good. 3k times negative 2 is negative 6k. Yep, I did it right. So you can double check. Okay? You guys are going to try C, D, E, F, G, H, I, J, up to J. So we have C, which we can take out a 2 and an X. We make sure you have an equal sign. If you don't have an equal sign, go back and put an equal sign. Then 8 divided by 2 is 4. X squared, take out an X is an X. Plus 10 divided by 2 is 5. X take out an X, done. Box it. Remember, you can distribute back and see, yeah, I get 8x squared plus 10x. I'm good. This one I can take out a 4. Make sure you have an equal sign. 12y divided by 4 is a 3 and a y. Minus sign. 16 divided by 4 is 4. Then make sure you can't take anything else out. You can't. Now, E, I'm going to show you the longhand because most people didn't spot the 15 right off the hop. So I want to show you that if you don't spot it, which is totally fine, that you just have to do 2 steps. So say I take out 5, which most people did first. They took out a negative 5 and a d cubed. If I take out a negative 5 out of negative 15, I get 3. d5 take out a d3, I get a d2. Plus 45 divided by negative 5 is negative 9. So instead of plus sign, I'm going to have minus 9. And then the d cubed came out. And now say you look at the bracket and you're like, wait a second, I can still take out a 3, right? So if I take a 3 out, now, the 3 is going to join the negative 5, and I'm going to get negative 15 d cubed. Take a 3 out of that, I get d squared minus 3. So had you just taken the negative 15 out right away, you'd still get the same answer. But if you don't, no big deal. Do a second step, right? Not a problem. Yeah?
So it's the same thing if you just take out a 15, not
Yeah.
negative 15.
If you take out a 15, you're going to
Negative
have
plus.
negative d squared plus 3. 15, can't take out anything. It's done. It's a trick question. And 15. 15 starts with the letter F. Yeah, I don't know where that is. Sure. Genius. Okay. G. G. We have C cubed plus C squared minus C. What can I take out? C. So when you take a GCF out of 3 terms, in your brackets, you better have 3 terms. That's the key thing. GCFs literally just simplify. They don't make anything go away. So if I have 3 terms, I'm going to have 3 terms left in my brackets. So if I take out a C out of C cubed, I'm left with C squared. A C out of C squared, I'm left with C. Negative C divided by C is negative 1. Most people can get this correct. Remember, you have to check. So C times C squared, C cubed. C times C, C squared. C times negative 1, negative C. This is the thing I need you to do. This is where people mess up, so I'm going to star it just to prove a point. If I had given you C cubed plus C squared plus C, what would you take out? A C. And I would be left with C squared. C squared take out a C plus C. C divided by C, what do people tell me it is?
1.
It is 1. Most people will tell me it's nothing. They just get rid of it. So don't draw this bracket, because I'm wrong doing this. If I go like this, remember you should be able to check yourself, correct? C times C squared is C cubed. C times C is C squared. C times, oh crap, I can't get the C back, right? So it's actually a plus 1. And I star this. Why do I star this? Because I really like stars? No, I star this because everyone gets it wrong. 90% of the class, if this is a test question, will not write 1, they'll just make it go away, which is wrong. So if you take a GCF out of 3 terms, you should still have 3 terms. Okay, does that make sense? If you take a GCF out of 2 terms, you should still have 2 terms. So if you take a C directly out of C, it's a 1. If it's like 3 divided by 3, it's 1. You still have a 1 left over every single time. Because when I go to distribute it back in, I need to have that 1 to get it back. Okay? For H, I can take out a 6. Can I take out an N? No. So I'm going to get n squared. Negative 30 divided by 6 is negative 5n plus 7. And there's nothing that multiplies to give me 7 and adds to give me negative 5. So I actually am done. I can't factor that anyways, even if it could, even if I wanted to. I could take out a what? A nothing. Or I could take out a negative 1. What happens when I take a negative 1 out? Everything stays the same, but the signs all change. So negative 7m squared divided by negative 1 is 7m squared. Negative 10m, take out a negative 1 is positive 10m. 17, take out a negative 1 is negative 17.
Do you have to do that?
The point of doing that is remember that we're not just factoring in this unit. It's called rationals. So this is just a review prepping us for the rationals lessons. Now in the rational lesson, the top you might be able to take a negative 1 out, and the bottom you might be able to take a negative 1 out, and they might be able to cancel. And your answer won't have those negatives in it. So there is some times where taking that negative 1 out has to happen, or your multiple choice will not answer. Will not answer. Your answer will not match your multiple choice. The multiple choice will not answer makes it happen. Okay. J, what can we do?
9p.
Take out a 9p. Make sure you have an equal sign. If you don't, go back and put in your equal signs. 18 divided by 9 is 2. I have p3, take out a p, I have p squared. Minus 63 divided by 9 is 7. P squared, take out a p is a p. Negative 9p divided by 9p is negative 1. K. What can I do with K? What can I take out? Yep, I'm asking you now though. What can I take out of K? They're both even, so I can for sure take out a what? A 2. If they're both even numbers, you could at minimum take out a 2. So this one is 18, ends in an 8, this one ends in a 0, I can take out a 2. So I take out a 2, and I have 18x squared, which is actually 9x squared, minus 50 divided by 20 by 2 is 25, y squared.
Wouldn't you take out an x and a y?
Nope, because it has to come out of both. Now most people think they're done. Remember, there's 2 things that we can do, 2 factoring things in 30-2 that I can ask you to do. One of them is GCFs, the other is difference of squares. How do you spot a difference of squares? It has to have 2 terms and a minus sign, and on both sides it has to be a perfect square. So I'm going to show it over here so you can see it. So we have 9x squared. I'm just going to show it over here just so you can see what I'm talking about. So in order for it to be a difference of squares, it has to be a difference of perfect squares. Like they gave a really good word, 3 words. Difference of squares. It has to be a difference, subtraction of squares, perfect squares. Like, couldn't have picked a better word to use to give this one away. So what does of squares mean? Well, if I take the square root of this, I can't get a bracket. I can't get a bracket. Wow, I knew now. I can't get a decimal. This is what I want to say. So the square root of 9 is 3, and the square root of x squared is x. Perfect squares only happen with exponents that are even. So the square root of x squared would be x. The square root of x4 is x to the 2. Square root of x cubed is x to the 3. So when your exponent is even, you can take the square of it. And then the square root of 25y squared, what's square 5y. So did either of these turn into decimals? Nope. And this is a difference sign. So difference of squares. It can happen. So what do I do when I have a difference of squares? That 2 is going to stay there, and this is going to turn into 2 factors. What I get from the first part goes in the front of each bracket. So 3x and 3x. What I get at the back goes into the back of the brackets. 5y and 5y. And then, do you remember what signs have to go in there?
Yes.
Opposites. Plus or minus. Why do we do opposites? Do you remember why?
It just works to make it big.
When you do opposite signs, it gets rid of those middle, the O and the I in foiling. I'll show you. So, remember I should be able to check this back. 3x times 3x is 9x squared. Yay. Outside, 3x times negative 5y is negative 15xy. 5y times 3x is positive 15xy. What happens when we have negative 15xy and positive 15xy? They go away. We're getting rid of that middle term. So the O and the Oi and the O and the Oi. Oi, oi, oi. The O and the I in FOIL. I'm going to lay in this little box on the floor and have a little nap ski. Okay, don't even have to wear my mask because I'm far enough away. Maybe it's the oxygen level from all the masks wearing. I don't think so. I think it's just.
So aren't you getting your ozone?
I know. It's the ozone. It's the ozone from the carbonated beverage. Okay.
Brain break this class.
So the O. No. The O and the I cancel off, and we're left with the last terms. 5y times negative 5y is negative 25y squared. Boom. So if you want a difference of squares, you have to use opposite sides so we don't get that middle term. So we only get 2 terms instead of 3. Okay? With L, what can I take out?
Take out 25.
25 what?
Or 25 Z5.
100 divided by 25 is?
4.
And then Z9, take a Z, Z4. Plus 50 divided by 25 is? 2. And Z. 75, take away 20, divide 25 out? Negative 3, and then the Z5 cancels. Then you're going to flip over. What's on the back? More stuff. Difference of squares is what's on the back. Try them out. Oh. So we have b squared minus 64. We discussed that one already. Square root of b squared is b. Square root of 64 is 8. What happens if there was a plus sign between these? Could I still do b plus 8, b minus 8? No? It would just be done. You couldn't do it. B squared plus 64, you would just box it and you move on. There's no such thing as addition of squares. You can't do it. So if there was a plus sign in there, we would stop. That would be it. But there's a minus, so we get b plus 8, b minus 8. The very first thing we should always ask ourselves is, can we take out a GCF even if we see a difference of squares in it? Okay? Can I take anything out of here? Nope. Square root of a squared is a. Square root of 144 is 12. And we have subtraction sign, so it's a difference. So we go a plus 12, a minus 12.
Does it matter if the sign varies search?
Nope. You can put them in either order. It doesn't matter which way the signs are. But please always check for GCF and then check, are they squares and is there a different sign? Because people will try and do it for an addition and you can't. Okay, 9 and 121, I can't take anything out. 9a squared is 3a. 121, square root of that is 11. So we're going to get 3a plus 11, 3a minus 11. X squared minus 81, the square root of x squared is x. The square root of 81 is 9. So we're going to get x plus 9, x minus 9, yeah?
Make a motion.
Yeah.
Thank you.
E, can I take anything out of that? Nope. What's the square root of 324? And 289, is it 17? So we're going to get 18a plus 17, 18a minus 17. (81 minus m squared). I'm going to talk to you about this one, so we're going to pay close attention. So we can go directly like this, and we can square root it. It'd be 9 and m. And so I would have to go 9 minus m, 9 plus m. It has to be in the order that they're listed. But sometimes, in order to match for rationals, we're going to want m plus 9 and m minus 9. So another thing we can do, so this is 9 minus m, 9 plus m, which wouldn't match m minus 9. What we would do here, make sure you're paying attention, is we could take a negative 1 out, and then we would get negative 81 plus m squared, which I could rewrite as negative 1 m squared minus 81. So remember, taking that negative 1 out just switches the signs, right? And so then I would get negative 1 m minus 9 m plus 9. And the reason why I would do that is if, when we're doing a rational, because we're not just factoring, we're going to do rationals, if I had m minus 9 on the denominator and I want them to cancel off, which is what we're going to do, we're going to be canceling, we might have to take the negative 1 out to make these be the right actual signs to be able to cancel them. So keep that in mind. We might take a negative 1 out when it's weird like this. 25x squared minus 1. People do not spot this one as a difference of squares. You did because it's on the page of difference of squares. You have to watch yourself. When it's a 1 is a perfect square. The square root of 1 is 1. But a whole bunch of you will not make that a difference of squares. You just won't. You'll spot 289, but you won't spot 1. Why do I say that? Because I've taught this since 2012 when the curriculum came out, and people will miss the 1. Okay? So, square root of 25x squared is 5x. Square root of 1 is 1. So we're going to get 5x plus 1, 5x minus 1. Now h, a lot of you will give me the answer 2x minus 6, 2x plus 6, which won't be on the test. That answer won't be there. So you would have went 2x minus 6, 2x plus 6. The problem with this is I can take a 2 out of each of these brackets. So I would have to keep going. I go 2, x minus 3, 2x plus 3, and then I have to bring my 2's to the front. 2 times 2 is 4, x minus 3, x plus 3. And that would be the actual answer that I should have. Or, like I said to you first, if you just look for a GCF right off the bat, this is easier. What can I take out of 4x squared minus 36? A 4. And then I'm left with x squared minus 9. And that gets me x plus 3, x minus 3. Which method is better? This one's easier. But which one's better? Did I get the same answer? So which one's actually better? Neither. Whichever one's easier for you. And sometimes you won't spot the GCF. No big deal. Spot it in the next one. Okay? Totally fine. The only right way to do this is the one that gets you the right answer. Both of them get you the right answer. This one just takes you a bit more steps to get there. Okay? I'm going to flip over. So we'll deal with non-permissible values here first. Non-permissible values are the value or values for the variable that would make the denominator equals 0. Because you can't divide by 0. So rational expressions are when you get like a variable over a variable, or a number over a variable, or a variable over a number. Those are your rational expressions. So we're going to end up with denominators that have variables. The moment we have a denominator with a variable, we have non-permissible values because it can't equal 0. So if we had an example, like a rational expression of 4 over x, most simple rational expression I could give you. Our denominator can't equal 0, correct? So what could we make x be that would make our denominator be 0 in this case? For 4 over x. What could we make x be that would make this denominator be 0? x is on the denominator. What could we put in for it that would make it be 0? Not a trick question.
What's the negative 4? What is the negative
On 0.
side?
Yeah, at 0. It would be 0. If you made actually x equal to 0, the denominator would be 0, right? If we said x equals 0, if I gave you this rational expression and I said x equals 0, we have a problem. Because now I have 4 divided by 0. Type that in your calculator. Go 4 divided by 0. It's going to get mad at you. It's not going to be happy. What does it say?
Error.
Error. You can't divide by 0. So whenever we have variables in our denominator, we have to state restrictions on the variables. Restrictions are NPVs. They can use these separately. Restrictions are non-permissible values. So the moment we have variables in our denominator, letters in our denominator, we have to state values, but that variable can't be, because if it was that number, we would have 0 in our denominator, which is the problem. We did this last year, whether you were -1 or -2. Okay? So we actually have to say x cannot equal 0. That's our non-permissible value. That's our restriction. So for that example, our restriction would be x cannot equal 0. Yeah. Yeah. So we have to figure out what x can't be. Okay. So we're going to go through and do some examples. So steps to finding NPVs. In order to find a non-permissible value, the first thing we're going to do is we're going to go to our rational expression and we're going to factor it. So GCF or difference of squares, numerators and denominators. So if I go to the top of this rational expression, consider the rational expression x plus 1 over 5x squared minus 5x. The first thing we're going to do is we're going to look at the numerator and the denominator separately. Is there anything I can do to x plus 1? Is there a GCF I can take out?
Nope.
It's for sure not a difference of squares because there's not a difference sign. So the only thing I can do is possibly take out a GCF, and I can't. It's x plus 1. So the numerator is going to stay the same, x plus 1. So we can go x plus 1 over 5x squared minus 5x equals, because every single time we do these rational expressions, we have this rational expression equals, this rational expression equals, this rational expression equals. We have equal signs in between each. So we have x plus 1 over 5x squared minus 5x. On the top, we still have x plus 1 because there's absolutely nothing I could do to it. Now, everyone paying attention. I've taught this for way too many years, and I know where people make mistakes. Do we trust me? Okay. So if something is attached by a plus or minus sign, it's as if they are sewn together. Okay? Think about it that way. So if things are attached by a plus or minus sign, so they're terms that are attached by a plus or minus sign together, we're going to pretend as if they are sewn together. They cannot come apart. Okay? So currently, I have x plus 1. So x is being sewn to 1. We agree they're sewn together? So the best way to make yourself remember that they're sewn together is the moment that anything is attached by a plus or minus sign, put brackets around it. So you know it's one whole thing. This is like a head, this is feet, this is the body being connected. This is one thing. So whenever I have plus or minus signs in something connected, I'm going to put brackets around it. You can choose not to. It will go poorly for you. Okay? I promise you it will not go well. I used to not make people do it. Unit was very poorly done. Okay? So I know putting brackets around it will help you. So if you have something plus something or something minus something, they're sewn together, you put brackets, so you know it's one whole thing. You can't split them apart. Okay? That means I'm not going to be able to cross something off out of it. It is one whole thing. On the bottom, I have 5x squared minus 5x. So the first thing I do is I GCF difference of squares at the top, GCF difference of squares at the bottom. Can I do either of those options to the bottom?
Yeah.
What can I do? I can take out a 5 and an x. So I go 5x on the bottom, and then I open a bracket because I'm GCFing. If I'm taking something out of 2 terms, how many terms better be still in this bracket? 2. So 5x squared take out 5x, what am I left with? X. And then 5x take out, negative 5x, sorry, take out a 5x, I'm left with that? Minus 1. Now do you see those are sewn together? We agree? They're sewn together? I put them in brackets, yes? Now the 5 and the x, are those sewn together?
No.
No. There's no plus or minus sign between them. So I'm going to put brackets around each of them separately because they are separate from each other. They're not attached by plus or minus signs. Yeah? Yeah. Okay. Do you want to see what I was Wagner back in the day. Miss Wagner, first year, teaching Math 10 pure, bad things happen. Okay? What was the bad things? We had canceling that I didn't even know was going to happen because it was the first time I taught it. And I was like, what is going on? I gave the first quiz and it was just like a disaster of epic proportions. So say we had this exact same thing, x plus 1, and then we had 5x squared minus 5x. Okay? I got things I didn't even imagine. Like even if I was like in my little mind of being 20, I don't remember how old I was, 23, 24, and I was like, what could they possibly do wrong? I couldn't even imagine this. I didn't even imagine. So you guys will do this if you don't use the brackets. You're going to go, hey, there's an x on both. Boom, boom, boom. Maybe even take one of those out. Like you just cancel like crazy people. You can't do that. Like crazy things happen. I had like +7 at the end. I was like, that is how did you even, what happened? I was like, okay, let's retry this again. Reel it back. No one knows what they're doing. Reel it forward. We don't want to get to that part. We don't want, I know it can happen. I know the bad things that can happen. We don't want that to happen. So actually, what I would suggest you do on these questions is in the very first rational, I put brackets. So I bracket this bad boy, because it's stuck together, and then 5x squared minus 5x, those are sewn together too. So I put brackets right around them too. The moment you have brackets, the only way you're getting rid of anything in that bracket is if the whole bracket matches another exact bracket in the numerator and denominator. So do these match completely?
Nope.
This black one and this one? Nope. So I'm doing nothing. The only thing I can maybe do is GCF for difference of squares. Make them match. Now if I go to this one here, do any of these match? Nope. So they're staying. Nothing's happening. Do I have a 10 on the top where I could cancel the 5? No. Do I have a single x up here somewhere? No. Do I have an x squared? Because then I could maybe cancel one off for one. Do I have that? No. I have an x plus 1 in the top, and I have an x minus 1 in the top. And no matter how pretty and close they look, they are nothing alike. It's like saying, oh, one is a plus, one is a minus. They're very close. It would be like saying that Elizabeth and I look the same. We do not. We are female. That is all we got going for us here. That's the same. These people have x plus 1s and an x and a 1. That's it, right? We're not the same. We can't cancel each other off. So don't go canceling those off. You're like, of course you're not the same. And then you cross these off. That's what you do. It's the same thing. Yo.
You're really low.
We already worked through that. I'll look in a second. I don't even know what. Okay. Yes, I did, and she's probably totally fine with that. Okay, thank you. We're going to work through these things. All right. So, I can't cancel anything off, correct? But, even if I could cancel something off, I would not. Because I need to state non-permissible values before I cancel. I'm going to write that. You need to state NPVs before, stop please, you cancel. I don't know why that L's so far away from the cans, but it's with it. So, we must state non-permissible values before we cancel. The moment there is a variable in the denominator, we have non-permissible values. We have values that variable cannot be. Okay? Does this 5 have a variable? No. Can 5 ever be 0? It's a really stupid question because it is a really stupid question.
Yes.
Can 5 ever be 0? No. You guys will tell me x can't be 0 because 5 can't be 0. I'm like, well, that's true, but 5 will never be 0. So we don't have to state a non-permissible value when we just have a number in a bracket, because it's 5. It can't be 0. There's no way it can be 0. It's the number 5. Okay? In this bracket, do we have a variable? Yes. It's just an x. When we have just an x, x will not be able to equal 0. So when it's just an x, our non-permissible value for that is 0. Now, how does that make sense? Well, if I take 5, say I put a 0 in, right? I can check these. I can check these. As long as my denominator becomes 0 when I put that in, then I'm right. So if I go 5 times 0 minus 1, because I'm putting zeros in this time, right? I would get 5 times 0 times negative 1. What's 5 times 0 times negative 1? It still equals 0. Did my denominator turn to a 0 when I plugged a 0 in for x? Yep. So this is good. This is a non-permissible value because I don't want it to turn to a 0. Okay? So we checked 0. It worked great. Perfect. Okay? So we stated our non-permissible value for that one. Now we have x minus 1. So what do? This bracket has to turn to a 0. What would x have to be in order for this bracket to turn to a 0? 1, because 1 minus 1 is 0. So you can use reasoning, or if reasoning is not your thing, you could take that bracket. So I take this bracket, I say x cannot equal 0. Just set it equal to not equal 0. Take that bracket, x minus 1 cannot equal 0. And then I solve it out. Add 1. X cannot equal 1. So you can just take the brackets and set them not equal to 0 because they can't be equal to 0 and solve. Now let's check the 1 out. Okay, I'm going to have 5 times 1, because I'm filling 1 in from x, times 1 minus 1. 5 times 1 times 0 is 0. Did my denominator turn to a 0 when I plugged a 1 in as well? Yep, so it's an NPV as well. So x can't equal 0 or 1. X can't equal 0 or 1. So your goal is to GCF and difference of squares your numerators and denominators, and then whatever bracket in your denominator has a variable, you're going to set it not equal to 0 and solve for it. Because if it was that, it wouldn't work. It would get you a 0 in your denominator. So we're going to look at example 2. Yep. Determine the non-permissible values, restrictions for each of the following. So we're going to look at A. Do I actually care about the numerator? Can a numerator equal 0? Yeah. Go 0 divided by 5 in your calculator. Make your numerator be 0. Go 0 divided by 5. Get you 0, right? That's totally fine. It's just our denominator that can't equal 0. So if they're only asking for non-permissible values, I actually don't even care about the numerator. I'm just going to simplify my denominator. Is there anything I can take out of this denominator? No. Is there anything I could take out of the numerator? Let's do the numerator anyways. This is in brackets because it's attached by plus or minus sign, so is that. Can I take anything out of the numerator? Nope. So it would say 3a minus 1 in brackets. Can I take anything out of the denominator? No, it would be a minus 1. If I'm talking about NPVs, or non-permissible values, or restrictions, I actually don't care about the numerator, because the numerator can be 0. 0 divided by anything is 0. I only care about the denominator. So I'm going to take my denominator brackets. I only have 1. And I'm going to take what's in that bracket, and I'm going to set it not equal to 0, and I'm going to solve it. That's it. So I'm going to go a minus 1 cannot equal 0. How do I get a by itself? Add 1. A cannot equal 1. And then I can check it. Plug it back in. 1 minus 1 is 0. Is my denominator equal to 0? Yep. That's a problem. So A cannot equal 1 is true. Because if A equaled 1, my denominator would be 0, and I'd have problems. Okay? B. Let's look at B. B, I have a 4 in the top. There's nothing I can do. I'm going to put these in separate brackets because they're attached. I have a 4 in the top, so it's going to stay a 4. On the bottom, I have 2k squared minus k. Can I do anything to that?
Take out K.
I can take out a k. When I take a k out of 2k squared, I'm left with 2k. And a k out of negative k, I'm left with negative 1. And this k is in its own brackets, and that 4 is in its own brackets, right? Because they're not attached to anything. To do NPVs, the easiest way is once we GCF for difference of squares, we just take the separate brackets in our denominator, whatever's in them, and set them not equal to 0 and solve. Okay? So my two separate brackets, I'm going to go NPVs. My two separate brackets are k cannot equal 0, that's 1. And then I'm going to do 2k minus 1 cannot equal 0. So I just take the two separate brackets, whatever's in them, and I set them not equal to 0. Does everyone understand what I did so far? Because NPVs are a struggle. I just took what my two brackets were in my denominators, and I set them both not equal to 0. So I took k, set it not equal to 0, 2k minus 1, set it not equal to 0. That's all I did. Does everyone understand where I went for there? Now I need to solve them each separately. Well, this one's k, this one already k is by itself, correct? So that one's done. We box it. So we know one of our NPVs is k can't equal 0. So whenever we have a k or a k squared or a k cubed or a k to the 4 by itself in a bracket, our NPV for that's going to be k can't equal 0. This one we have to do more math though, because we haven't got k by itself, right? So we're going to have to solve. So we're going to add 1 to both sides first, because we have to do reverse bed math when we're solving. So we do addition and subtraction first, then multiplication and division, then exponents and brackets. We reverse bed math when we solve. So we're going to get 2k cannot equal 1, and then what do we have to do? Divide by 2 to get k by itself. So k cannot equal 1/2, and we box it. And what we do in the end is we rewrite them together. So we go k cannot equal 0, comma, 1/2, and box it. There's my NPVs. You guys try C and D. On the bottom we have 2 and m plus 5. The 2 is by itself. The m minus 5 is in the top. We have an equal sign. Does the 2 get me a non-permissible value? Is the 2 of a variable? Nope. So you could write 2 cannot equal 0, and you're like, yes, you're a genius. That's true. 2 doesn't equal 0, but it's not an NPV. Okay? But you could write it. It's a true statement. That is true. Now, m plus 5 cannot equal 0. Subtract 5. M cannot equal -5. This one, we have x minus 3 over, and then the square root of x squared is x. The square root of 49 is 7. So we get x plus 7, x minus 7. The x minus 3 stays in its own bracket. Do I need to state non-permissible values for the x minus 3? No, because it's where? It's in the numerator. Oh my gosh, this is caught on my earring. You could have a mask for life. Okay, now, so if we take the x plus 7, we're going to say NPVs so that we know our restrictions. X plus 7 cannot equal 0, and then we have x minus 7 cannot equal 0. This one we're going to subtract 7. X cannot equal -7. So we're going to add 7. We're going to have x cannot equal plus 7. And so they write it always together like this. X cannot equal positive minus 7. If you wrote it separately, you went -7, comma 7, you're fine. It's just in the multiple choice to show like that, yeah?
That's in math, you can just do it.
Those ones you can just do. You just have to watch because like the 2k minus 1, people will tell me it's plus 1. It's not. Because I have to move the 1 over and then divide by 2 so it's a half. The more you do NPVs, the more you'll see the non-permissible values and not have to do all the math to get there. Okay? No. Here's your turn. This is your homework. A, B, C, D.